Hi, everybody. Happy Tuesday. I just want to start off by saying that you guys did an awesome job yesterday. It was a lot of new information, a lot of new content, and that is not easy to learn virtually. And you guys honestly just knocked it out of the park. So you should be very proud of yourselves. That made me really excited for this week to go on as we continue with this material. So great job. Very proud of you guys. Today, we are going to quickly review what you guys did yesterday. So we're going to talk about the transversal and the parallel lines, talk about the two angle relationships that you guys learned about, and then I'm going to introduce two more to you today. And then we'll talk about your assignment at the very end. So essentially, your objectives, long story short, you are looking to identify different angle relationships within that diagram that we've been looking at. And with that knowledge of the relationships, you should be able to identify unknown angle measures and set up different equations to solve for missing variables. So it's a lot in there, I know, but you guys are capable and you can do it. So we know that this is our go-to diagram at this point. This is the transversal that cuts the two parallel lines. We know that the transversal is represented by the letter T, and then L and M, those are our parallel lines. So the 8 relationships that kind of take place, we know that we can identify those missing angle measures with our knowledge of angle relationships. So let's do a quick review from yesterday. So this was relationship number 1. So right away, you should see that these two identified angles are on opposite sides of the transversal, and they're inside of those parallel lines. Knowing that, you know that they're going to have to be alternate interior angles. Oops, sorry. They're alternate interior, opposite sides and on the inside, and because they're alternate interior, they are congruent. So if angle 4 was 100, 5 would be 100. If 3 was 60, 6 would be 60. The second relationship was similar in the sense that the two angles were on the opposite sides of the transversal, but notice now the two angles are on the outside of those parallel lines. Therefore, their relationship type is alternate exterior. Okay, exterior because they're outside. That means because they're alternate exterior angles, they are congruent. So if angle 1 was 100, angle 2 would be 100. If angle 1 was 40, angle 2 would be 40. These are the two final angle congruent relationships that we're going to look at today. So we're going to talk about vertical angles and we're going to talk about corresponding angles. So if you have your notes, this is what you're going to want to add to it. So let's get started with vertical angles. These are angles that can be defined as ones that are across from one another. So notice you could circle 4 and 3, those are vertical. You could circle 1 and 2, those are vertical. 8 and 7 are vertical. 5 and 6 are vertical. I always use kind of like a loop, like I mentally draw that for myself, knowing that, okay, if you can circle them as being across from one another, like diagonally, those are vertical. And they will be congruent. So if I told you that angle 4 was 100 degrees, 3 would be 100 degrees. If angle 5 was 30 degrees, 6 would be 30 degrees. So now let's use that knowledge to identify different vertical angles here. There's 4 different pairs of vertical angles. So first, we've got 1 and 4, as you can see with my cursor here. You've got 2 and 3, 5 and 8, and then your last one is 6 and 7. Now, knowing that vertical angles are congruent, we can apply that knowledge with expressions and equations. So if I gave this to you and I said, I want you to solve for x, hopefully you know that because those two angles are across from one another, and we can circle them, that they're congruent or they are equal because they're vertical. So because they're vertical angles, you can set up 16x minus 32 is equal to 12x plus 8. They're equal because they're vertical. Now it's just a game of solving the equation. So if you've got 16x and 12x, I know 12x is smaller, so we're going to move that to the other side. And I'm left with 4x minus 32 equals 8. With this minus 32, we're going to do the inverse, which is plus 32. And we're left with 4x equals 40. Divide both sides by 4, and you get x equals 10. So in sum, because these two angles were vertical angles, we could set them equal to one another, and then you can solve for x. The next angle relationship that we're going to look at is corresponding angles. This typically is usually the most challenging for kids to identify, so I have a few slides to help you. When we think corresponding, we think same spot or same position. So corresponding, same position. If they're corresponding and in the same spot wherever they are congruent or they are equal. So notice these two angles here in the diagram in blue, they're in the same exact spot, top right. They're in the same spot, they're the same position, they are congruent. If this guy was 30, this guy would be 30. I'm going to show you a few diagrams and give you examples of what corresponding angles look like. So here we go. So 1 and 5, notice they're in the same position, top left, top left. 2 and 6, top right, top right. 3 and 7, bottom left, bottom left. 4 and 8. Let me show you one more time. Corresponding, so they're congruent. Those are corresponding. Those are corresponding. Those are corresponding. If they are corresponding, they are congruent, they are equal. Now let's use that to kind of identify them further. So in this diagram, there are 4 corresponding angle pairs. 1 and 5, 2 and 6, 3 and 7, 4 and 8, because they're all in the same spot. So if I gave you an expression that looked like this, and I wanted you to solve for x, first of all, hopefully you can identify like, oh, these are corresponding angles. They're in the same spot, top right and top right. That means that they're equal. So you can set those two expressions equal to one another to solve for x. And that's exactly what we did right here. This is another game with variables on both sides. Find your smaller term and move it to the other side. When I do that, 10x minus 7x gives me 3x, and then I still have minus 26 equals 40. I want to get rid of this minus 26, so I'm going to add it to the other side. Now I've got 3x equals 66. Divide both sides by 3, and you get x equals 22. So the reason that I could set those equal to one another is because they're corresponding angles. They're in the same spot, they're equal to one another, so you can take both expressions and set them equal to one another. Now, here's where we can push it one step further, and this is really thinking about your high school math classes. This is where we need to get to. So it's not asking you to solve for x, it's asking you to solve for the measure of angle 1 right here. Okay, we don't have anything in angle 1. All we know is that we've got this expression and this expression. First of all, if I was walking through this myself, here's what I'd ask myself. With those two angle expressions, what relationship do you see? So I see that because it's in the top right and the top right, those are in the same spot. That means that they're corresponding angles. Now, are corresponding angles congruent or supplementary? They are congruent, which means they're equal. That means that we can set the two expressions equal to one another to solve for x. So notice I've got 8x minus 4 equals 6x plus 8. You can pause the video and see all the work that came out here, and then you get to x equals 6. But the question asks you to solve for angle 1. Well, we know that these two angles here, angle 1 and 6x plus 8, are actually equal. They're vertical angles. They're across from one another. Because they're equal, you can just plug in x as 6 for this guy here, the 6x plus 8, and that whatever that angle measure is, that'll be the same as angle 1 because they're vertical and they're congruent. Now, when I did that, here's what it looked like. So instead of 6x plus 8, I removed my x and I substituted a 6. 36 plus 8 gave me 44. So because this expression gave me a value of 44, it's congruent to angle 1 because it's vertical, so that's also 44. So let's quickly sum up here together. Let's go back a few different slides, sorry. We know today that we talked about vertical angles. Those are angles that are across from one another that you can like circle them diagonally. Those are congruent. So wherever you see vertical angles, those are congruent. We also talked about corresponding angles. Corresponding means same position. So think about your transversal broken up into your top 4 and your bottom 4. If you've got something in the top right here, it's going to be congruent to this top right down here. They're corresponding, they're congruent, and they look just like that. So we can use our knowledge of this to help us solve equations and to identify missing angle measures. So your assignment for today, for Tuesday, is to complete the vertical and corresponding angles quizzes. If you want, you can just quickly write down the code. I put it on the screen for you, or the link is in the e-learning folder. It is also linked in the post this morning. So Other than that, I know that was so much information given to you. If you need to go back in the video and take a picture of the slides, that would be a good idea. Other than that, please know how proud of you guys that I am. I know I'm not with you in person and I'm not standing at the smartboard, but I still think of you guys every single day, and I worry about how you are and if you're okay and you're happy and if you're learning. So if you need me, I'm here, but I'm very proud of you guys. Have a great day.